Hello students, our last lesson we have discussed carbon, the allotrope of carbon, the property of carbon and so on. Today's lesson we are going to discuss the compound of carbon, two gases of carbon, that is carbon dioxide gas and carbon dioxide gas. This is the most stable. Now let me start the first one, carbon dioxide gas. This is the most stable oxide of carbon. In carbon dioxide gas, the carbon atom forms strong covalent bond with two oxygen atoms. Carbon dioxide gas is a molecular substance. The gas accounts for 0.03% of the volume of air. How can we prepare carbon dioxide gas? Here now we have the setups. I hope by now you must know the names of these apparatus. Here we have separating funnel, we have this one, the delivery tubes, a gas jar, a conical flask, and so on. In the first conical flask, it contains calcium carbonate. We add diluted hydrochloric acid. So remember, from one we have learned property of acid. We have said acid, when it reacts with carbonate and hydrogen carbonate, they form salt plus water plus carbon dioxide gas. So for us to prepare carbon dioxide gas, we need to react acid and carbonate. So after reacting dilute hydrochloric acid with calcium carbonate, it forms water. Water remains here. Calcium chloride as salt remains here, but the carbon dioxide gas passes through the delivery tubes. In the second conical flask, it contains sodium hydrogen carbonate. The role of sodium hydrogen carbonate is to remove the traces of hydrochloric acid. Instead of this one, we can use water. You can either use water or you can use sodium hydrogen carbonate. Their role is to remove the traces of hydrochloric acid or the fumes of hydrochloric acid. So carbon dioxide gas passes through the next delivery tubes. In the next conical flask, we have concentrated sulfuric acid. Remember, we have two commonly drying agents. One is anhydrous calcium chloride. Anhydrous calcium chloride, the role is to dry the gas, is to remove moisture, is to absorb moisture. The other commonly drying agent in the laboratory is concentrated sulfuric acid. I hope you are seeing this one. The two commonly used as a drying agent is calcium chloride and concentrated sulfuric acid. And their role is to dry the gas. These are the two commonly used drying agents in water. So in this case, water, in this case carbon dioxide gas, when we pass through a concentrated sulfuric acid, we get a dry carbon dioxide gas and we collect by downward delivery tubes. Remember, we have three methods that we can use to collect gases. One is by overwater. A gas that is collected by overwater is either insoluble in water or slightly soluble in water. Example, we have oxygen gas, hydrogen gas. Hydrogen gas is insoluble in water, we can use to collect by overwater. While oxygen gas is slightly soluble in water, that's why we collect by overwater. Also, we have when the delivery tubes is passing downward, it's called downward delivery tubes. Like in this case, carbon dioxide gas is collected by downward delivery tubes. Therefore, hello guys, I'm sorry. So we have said carbon dioxide gas is collected by downward delivery tubes. The gases that we use to collect by downward delivery tubes, those gases are denser than air. Denser than air, such as carbon dioxide gas is denser than air. That's why we collect by downward delivery tubes. We have another method where delivery tubes is looking upward. This one is called upward delivery tubes. The gases that we collect by upward delivery tubes are less denser than air. So you must know these three methods. Overwater means the gas is either insoluble or slightly soluble in water. Downward delivery tube means the gas is denser than air. Upward delivery tube means the gas is less denser than air. Then they told us that the equation between calcium carbonate and dilute hydrochloric acid is here. They form calcium chloride as salt plus carbon dioxide gas plus water. And here we have a chemical equation. Next question, they told us explain the purpose of sodium hydrogen carbonate in this setup. The gas is passed through sodium hydrogen carbonate or water. You can either use sodium hydrogen carbonate or you can use water to remove the traces of hydrochloric acid fumes in the gas. For us to remove the traces of hydrochloric acid, we have to pass through water or sodium hydrogen carbonate. When required to dry the gas, we can use concentrated sulfuric acid, which act as a drying agent. Drying agents are those substances that is used to dry the gas, such as concentrated sulfuric acid or anhydrous calcium chloride. Anhydrous calcium chloride can be used in place of concentrated sulfuric acid as a drying agent. So remember these two substances, anhydrous calcium chloride and concentrated sulfuric acid, act as a drying agent. Any other carbonate can be used with a suitable acid. But remember, dilute sulfuric acid should not be used, should not be reacted with calcium carbonate, barium carbonate, and lead carbonate. This is because insoluble salt, insoluble sulfate produced forms a coating on the carbonate and prevent further reaction. If you remember, we have said all sulfates are insoluble. All sulfates are soluble in water except barium sulfate, lead 2 sulfate. So and calcium sulfate, which are slightly soluble in water. So when we are using sulfuric acid, you are not supposed to use with calcium carbonate or barium carbonate and lead carbonate because they form insoluble salt which coats on the surface of carbonate and prevent further reaction. Property of carbon dioxide gas. Carbon dioxide gas is a colorless gas or odorless gas. It is denser than air. It neither burns or supports burning. It does not burn. It does not support combustion. It is an acidic gas, and it is dissolved in water to form weak carbonic acid. At the stage of the gas, it forms a white precipitate with calcium hydroxide. The gas is denser than air, and this explains why this gas is collected by downward delivery tube. Carbon dioxide gas slightly dissolved in water to form carbonic acid, a weak acid. And here we have the equation: carbon dioxide gas plus water, we get carbonic acid. Remember, carbonic acid we write as CO3. Carbonate has valence 2, hydrogen has valence 1. So now here we get carbonic acid. Carbon dioxide gas plus water, we get carbonic acid. Then now we have, although the gas does not burn, does not support combustion, burning magnesium continue to burn in it and produce a white powder of magnesium oxide and black specks of carbon. The burning magnesium produces a lot of heat that decomposes carbon dioxide gas to carbon and oxygen gas, and therefore magnesium continue to burn with oxygen gas. They told us that carbon dioxide gas does not support burning, but it burns with magnesium because the hot magnesium decomposes carbon dioxide gas into two, carbon and oxygen. Since in form 1 we have said carbon, we have said oxygen is the active part of air that supports burning, so magnesium continue to burn with oxygen, and the product form here is magnesium oxide and carbon. Here we have the equation: magnesium plus carbon dioxide gas, we get magnesium oxide plus carbon. The color of magnesium oxide is white powder and carbon is black. Next, now we go to uses of it again. Uses of carbon dioxide gas. Carbon dioxide gas is used as a refrigerating agent for perishable goods. This is because solid carbon dioxide gas sublimes when heated and leaving no wetness and leaving no residue. Carbon dioxide gas is used to extinguish fire because it's non-flammable and has a higher density than air. Therefore, it forms a blanket on the surface, cutting off oxygen supply. It is used in manufacture of sodium carbonate in solvay process. We are going to discuss the next video called reading solvay process. Carbon dioxide gas is used in manufacture of sodium carbonate, a process called solvay process. Carbon dioxide gas is dissolved in water to make aerated drinks to add taste. It's also used in making baking powder. So we have done carbon dioxide gas. We go to another gas, which is carbon oxide gas, carbon monoxide gas. This is another oxide of carbon in which the carbon atom forms 3 covalent bond with oxygen atom. It's a molecular substance just like carbon dioxide gas. How can we prepare carbon dioxide gas? Carbon dioxide gas may be prepared by dehydrating methanoic acid using concentrated sulfuric acid. Dehydrating means the process of removing water or element of water from substance is called dehydration process. Substance that removes water or element of water from other substance is called dehydrating agent. So here now they told us that when we dehydrate methanoic acid, they form carbon monoxide, carbon dioxide gas, and here we have the equation. Methanoic acid in the presence of concentrated sulfuric acid which acts as a drying agent, they form carbon dioxide gas and water. So now when we add concentrated sulfuric acid to methanoic acid, this acid has the ability to remove water or element of water from substance. So it produces water and carbon dioxide gas. Carbon monoxide gas passes through the delivery tubes and we collect by water because it is insoluble in water. Here we have the chemical equation HQ. HQ is methanoic acid. We are going to learn when we reach form 3 and that will be called when we reach form 4, organic chemistry 2. When now we take a methanoic acid HQ, we add concentrated sulfuric acid which acts as a drying agent. They form carbon monoxide or carbon dioxide gas plus water. Also we can use ethene dioic acid, another name called oxalic acid. In place of methanoic acid, we can use oxalic acid may be used. When we are using oxalic acid or ethene dioic acid plus concentrated sulfuric acid which acts as a drying agent, we have said this one is the commonly used drying agent in laboratory. We get carbon dioxide gas and water. 2 oxide of carbon and water. So the water remains here, the carbon dioxide gas and carbon dioxide gas passes through the delivery tubes. In next test tube we have sodium hydroxide. If you remember, we have said sodium hydroxide is to absorb the carbon dioxide gas. In place of sodium hydroxide we can use calcium, we can use potassium hydroxide, group 1 hydroxide. We can use potassium hydroxide or sodium hydroxide. Their role is to absorb the carbon dioxide gas. So carbon dioxide gas is absorbed here. Remember we have said ethene dioic acid, another name called oxalic acid, when we add concentrated sulfuric acid which acts as a drying agent. Carbon dioxide gas and water are formed. The carbon dioxide gas and carbon dioxide gas passes through the delivery tubes where the second conical plus carbon dioxide gas will be absorbed by sodium hydroxide. We can use potassium hydroxide. So the remaining carbon monoxide gas, or we can call it carbon dioxide gas, now it passes through the delivery tubes where we collect by water because the gas is insoluble in water. And here we have the equation. Methane, we have oxalic acid, H2C2O4 oxalic acid. In the presence of concentrated sulfuric acid, we get carbon dioxide gas, carbon dioxide gas, and water. The gas mixture should be passed through concentrated solution of sodium hydroxide to remove carbon dioxide gas. The gas may also be prepared by passing carbon dioxide gas over heated charcoal. Remember, charcoal is a carbon. So carbon dioxide gas, when we add charcoal, when we burn the charcoal, it forms the carbon dioxide gas reduces to form carbon dioxide gas. because carbon is a reducing agent. Here we have carbon dioxide gas when we pass through or when we pass over heated charcoal. Remember, charcoal is a carbon. This one now reduces carbon dioxide gas to carbon dioxide gas. And here now in the first conical flask we have sodium hydroxide. The role is to absorb any carbon dioxide gas. So carbon dioxide gas will be collected by over water because the gas is insoluble in water. Next, now we have property of carbon dioxide gas. Physical property of carbon dioxide gas. Carbon dioxide gas is a colorless gas or odorless gas, slightly less denser than air. Carbon dioxide gas, it is colorless gas, odorless gas, and slightly less denser than air. It has a boiling point of negative 3.1 degrees centigrade. The melting point is because of the weak forces of attraction between the molecules. The gas is slightly soluble in water. The solution form is neutral. The gas is extremely poisonous. It combines with hemoglobin in the red blood cell to form a stable compound known as carboxyhemoglobin. The carboxyhemoglobin prevents formation of oxyhemoglobin leading to suffocation. That's why we normally say never burn a jiko in poorly ventilated room, because carbon plus limited supply of oxygen, it forms carbon monoxide. Once you inhale, it combines with hemoglobin, the red blood cell, to form a stable compound called carboxyhemoglobin, which now prevents the oxygen, the carrying capacity of oxygen, leading to suffocation. Chemical property of carbon dioxide. First of all, now we talk about combustion. Chemical property, we talk about the reactions. Combustion means burning. Carbon dioxide gas, when it burns in air with a blue, carbon dioxide gas burns in air to form a blue flame, to form carbon dioxide gas. So carbon dioxide burns with a blue flame and form carbon dioxide gas. And here we have the equation: carbon dioxide gas oxidizes to form carbon dioxide gas. Reducing property of carbon dioxide gas. Carbon monoxide, also called carbon dioxide gas, when we pass over heated cobalt 2 oxide. The color of cobalt 2 oxide here, or 2 oxide here, is black, but after it reacts with carbon monoxide, carbon dioxide gas reduces to form cobalt. Cobalt 2 oxide reduces to form cobalt, and itself carbon monoxide oxidates to form carbon dioxide gas. So observation, we observe the black cobalt 2 oxide turns to red-brown copper metal. Carbon monoxide oxidizes to form carbon dioxide gas, and in this conical flask we have lime water, is to show the gas, which is carbon dioxide gas. When it reacts with lime water, it forms a white precipitate. Remember, lime water is calcium hydroxide. Calcium hydroxide plus carbon dioxide gas is formed calcium carbonate and insoluble salt, and the color formed here is white precipitate. We have said carbon dioxide gas burns with a blue flame. So here now we observe 3 observations. 1. Black cobalt 2 oxide turns to red brown. Carbon dioxide gas, once it reacts with lime water, it forms a white precipitate. The remaining carbon monoxide, it burns with a blue flame. The following setup may be used to show the effect of carbon dioxide on hot metallic oxide. Carbon dioxide gas readily removes combined oxygen from metal low in the reactivity series such as copper, lead, and iron. In turn, oxidizes to carbon dioxide gas. Therefore, carbon dioxide gas is a reducing agent. We are going to see one by one. Carbon dioxide gas plus carbon monoxide. Cobalt dioxide gas plus carbon dioxide. Cobalt dioxide. Let me repeat again. The following setup that may be used. Let me start at this point. Carbon dioxide gas readily removes combines oxygen from metal low in the reactivity series, such as copper, lead, and iron. In turn, oxidize to carbon dioxide. Therefore, carbon dioxide is a reducing agent. Example, we have copper 2 oxide plus carbon 2 oxide gas. They form copper metal plus carbon oxide gas. The copper 2 oxide gas will be reduced to form copper metal, and in turn carbon monoxide oxidized to form carbon 4 oxide gas. The same to zinc oxide plus carbon 2 oxide gas. The zinc oxide will be reduced to form zinc metal, and copper 2 will oxidize to form copper 4 oxide. The same to lead and iron. Iron 3 oxide plus copper plus carbon monoxide. The iron 3 oxide reduces to form iron metal, and carbon 2 oxide oxidizes to form carbon 4 oxide gas. The reducing property of carbon 2 oxide make the gas useful in extraction of some metal from their ores. Other source of carbon 2 oxide. Carbon 2 oxide is encountered almost in everyday situation through combustion of charcoal, fossil fuels such as kerosene, tinsel, and petrol or coal. When the charcoal burns in the charcoal stove, GICO, three reactions occur in the various regions. So here now we have the GICO, charcoal stove, air. So the charcoal we have said is a carbon, so a plenty. Here now we have excess air. When it reacts with the first carbon atom, carbon plus excess oxygen, we get carbon plus excess oxygen, we get carbon 4 oxide gas. So this one, it should be carbon 4 oxide gas. The carbon 4 oxide gas in the region A, it reacts with the carbon in region B. So carbon 4 oxide gas plus carbon, they form, so carbon reduces carbon 4 oxide gas to carbon 2 oxide gas. So in the second region we have carbon 2 oxide gas. The carbon 2 oxide gas reacts with excess air outside region C to form carbon 4 oxide gas. So in region A we have carbon 4 oxide gas. In region B we have carbon monoxide gas, that's carbon 2 oxide gas. While in region C, the outer region, we have carbon 4 oxide gas. The region A in this region, plenty of air enters the GICO, allowing complete combustion of carbon to carbon 4 oxide gas. So region A, we have carbon react with excess and plenty of oxygen gas to form carbon 4 oxide gas. In region B, the carbon 4 oxide gas produced in region A raises up to react B where it is reduces. So carbon 2 oxide gas in region A reacts with carbon to form carbon 2 oxide gas. Region C, here now there are enough oxygen, therefore carbon 2 oxide gas produced in region B burns to form carbon 4 oxide gas. And here we have the equation. In case of insufficient air, some carbon 2 oxide gas produced in the region B is released into the atmosphere. This is common in poorly ventilated room. So God willing, next video we're going to finish the topic. We're going to discuss carbon and hydrogen carbonate and hydrogen carbonate. That will be the next topic, God willing. So let me summarize what we have learned today in this video. We have learned carbon 2 oxide gas and carbon 4 oxide gas. We have said this one are the two compounds of carbon. Carbon 4 oxide gas can be prepared in the laboratory. The reaction between dilute acid with appropriate metal carbonate, because from one we have said one property of acid. Acid, when it reacts with carbonate, they form salt plus water plus carbon 4 oxide gas. Example, we have taken dilute hydrochloric acid plus calcium carbonate, maple chip or calcium carbonate. They form calcium chloride plus water plus carbon 4 oxide gas. The gas should be passed through water. Alcohols contain water or sodium hydrogen carbonate. The role of these two substances is to remove the traces of hydrochloric acid. Then the gas is collected by downward, which passes through a container, a conical flask containing concentrated sulfuric acid. The role of concentrated sulfuric acid is to act as a drying agent. The role is to dry the gas. We can use anhydrous calcium chloride. These two substances, anhydrous calcium chloride and concentrated sulfuric acid, act as a drying agent. These two are the commonly used drying agent in the laboratory. Then the gas is collected by downward delivery tube because the gas is denser than air. Then we have discussed the property of this gas. We have said the gas is a colorless gas or odorless gas. It is denser than air. The taste of this gas forms a white precipitate with lime water because lime water is calcium hydroxide. Calcium hydroxide plus carbon dioxide gas, we get calcium carbonate, which forms a white precipitate. When we are using dilute sulfuric acid, you should not be used with calcium carbonate, barium carbonate, and lead 2 carbonate because they form an insoluble solvate. Since we have said all solvates are soluble in water except barium solvate, lead 2 solvate, and calcium solvate, which are slightly soluble in water. These three, they form insoluble salt and form a coat on the surface of carbonate, preventing further reaction. Then we have discussed the carbon monoxide gas, carbon dioxide gas. We can prepare carbon dioxide gas by dehydrating methanoic acid or oxalic acid. Dehydrating means dehydration process is a process where we remove water or element of water from substance. We normally use a concentrated sulfuric acid. We normally use concentrated sulfuric acid as a dehydrating agent. So when we react concentrated sulfuric acid to methanoic acid, they form carbon dioxide gas, and water. So carbon dioxide gas is collected by water because it is insoluble in water. In other way, we can also use oxalic acid, ethane dioic acid, called oxalic acid when we add to concentrated sulfuric acid, which acts as a drying agent. So it forms water plus carbon dioxide gas plus carbon dioxide gas. The two gases, that is carbon dioxide gas and carbon dioxide gas, is passed through sodium hydroxide or potassium hydroxide. And we have said that one is to remove carbon dioxide gas. So once sodium hydroxide removes carbon dioxide gas, what remains is carbon dioxide gas we collect by over water. Then we have discussed the uses of carbon dioxide gas, and their property. So property of carbon dioxide gas, we have said it's a colorless gas, also odorless gas. The gas is slightly soluble in water. The gas we call it a silent killer. This gas, carbon dioxide gas, is called a silent killer because the gas is a colorless, just like oxygen. The gas is odorless gas, but it can kill you. It can kill you silently. Because we have said when we burn charcoal with a poorly ventilated room, limited supply of oxygen reacts with carbon to form carbon dioxide gas. Once you inhale, it combines with hemoglobin to form carboxyhemoglobin, a stable compound, prevents carrying capacity of oxygen, which reduces carrying capacity of oxygen. Therefore, an individual will die due to lack of oxygen. We call it suffocate. We can also get carbon dioxide gas by burning charcoal or by passing carbon dioxide gas with a burning carbon or charcoal, because charcoal is a reducing agent. Charcoal is a carbon. Carbon is a reducing agent. It can reduce carbon dioxide gas to carbon dioxide gas. Also, we have discussed burning GICO. But during the next lesson, we are going to discuss carbonate and hydrogen.